Question 7.48. Block A and block B are forced together, compressing a spring with a spring constant K equals 2500 Newton per meter between them, 3 centimeter from its equilibrium length. The spring, which has negligible mass, is not fastened to either block and drops to the surface after it has expanded. What are the speeds of block A and block B at this moment? Assume that the friction between the blocks and the supporting surface is so low that it can be neglected. So you have block A of mass MA equals 1 kilogram. And then you have block B of mass MB equals 3 kilogram, which are forced together with the help of a spring that has a spring constant K of 2500 Newton per meter. After they are released, we need to find what are their speeds, VA and VB. Initially, both blocks are at rest. And if they are at rest, their initial momentum, Pi, is equal to 0. When they are released, the final momentum Pf will be sum of momentum due to block A and block B, which we can write as Ma times Va plus Mb times Vb. Now we know from the law of conservation of momentum, momentum before and after collision is conserved. That means initial momentum Pi must be equal to the final momentum. So we write 0 equals MAVA plus MBVB. After we arrive here, we can rewrite this expression in terms of any one of the velocity. I will write MAVA to be equal to negative MBVB. We move this to the other side, that makes it negative. And rearranging, we can get VA as negative MBVB over MA. Let us call this as equation 1. After using the law of conservation of momentum to find relationship between the velocities, now we are going to use the law of conservation of energy to find their values. We know from the law of conservation of energy, total mechanical energy at any 2 point in motion has to be equal. So if I take E initial to be the total mechanical energy when the two blocks are forced together compressing the spring, and E final to be the total mechanical energy when they are released, according to law of conservation of energy, these two energy values has to be equal. So E initial is nothing but the potential energy of the spring as it is being compressed, which we can write as half K delta X squared. This is the only energy present in the beginning as the two blocks are at rest and only the spring is being compressed. Final mechanical energy, on the other hand, will be sum of kinetic energy of the two blocks, which we can write as half mVA squared for block A plus half mVB squared for block B. Since the spring comes back to its equilibrium position, there is no spring potential energy at this point. Now we solve further to calculate the values of these velocity. Let us first cancel the half here. Then we are left with K delta X squared equals MAVA squared plus MBVB squared. Now, if you look at equation 1, we have relationship between VA and VB. We are going to substitute this in our expression here. So I'm going to write K delta X squared equals MA. In place of VA, we are going to write this negative MB over MA VB, the whole thing squared, plus MB VB squared. Now we can take the common terms outside. VB squared is present in both the terms over here, so we can take it out in a bracket. We write K delta x squared equals, let's take VB squared as common. Here we are left with MA. Negative MB, when you take square of that, just becomes MB squared over MA squared plus MB. I want to find what is VB. So we will divide by the term over here and take square root. So that gives me VB to be equal to K delta X squared over, you can cancel off the MA here and one of the MA from the denominator. And then we write whatever is left, MB squared over MA plus NB. And the whole thing in the square root. So let's calculate VB. We get VB as square root. K is 2500. Delta X is 3 centimeter. So 3 centimeter you can write as 0.03 meter. So we get this as 0.03 meters squared over MB is 3 kilograms, so 3 squared. MA is 1 plus 3. And when you solve this, you get VB to be equal to 0.433 meter per second. Now, once you found VB, you can find VA using equation 1. So we have VA to be equal to negative MB over MA into VB. So let's substitute negative 3 over 1 into 0.433. That gives me VA to be equal to negative 1.299 meter per second. So this is how you can calculate the final velocities of the two blocks using law of conservation of momentum and law of conservation of energy.